The Serial Wombat GRIP PCB0031 is an I2C Based 4-channel servo control board with 4 independent genuine Allegro ACS 712 current sensors for force feedback. An onboard Serial Wombat 8B chip allows offloading of real-time feedback tasks. This allows powerful robotics and other servo operations such as force feedback-based servo grippers. Servo rate of movement control can also be offloaded to the Serial Wombat chip, making it easy to control multiple different servos at different speeds. The grip board is convenient to use. Power for servos can be provided through header connectors, screw-down terminals, or a power-only micro USB connector. Screw-down terminals and dual I2C VDD connectors make it easy to chain multiple boards together. I2C addresses between 0x60 and 0x6F can be selected via onboard jumpers. Onboard I2C pull-up resistors and VDD and power indicator LEDs can be enabled with solder jumpers. A solder jumper connection allows the last servo channel to be repurposed to measure servo voltage input instead of to drive a servo. The open-source firmware on the Serial Wombat 8B chip is frequently updated and can be downloaded in-circuit using the I2C Based bootloader from an Arduino or MicroPython sketch. The force feedback capability of the grip board is shown here. A simple sketch calls powerful Serial Wombat library routines that automatically calibrate a servo gripper's range of motion and current draw so that many grippers can be used without manual calibration or measurements. Success or failure of a grip attempt can be detected by the final stop location of the control algorithm, and the size of a gripped object can even be inferred. In the first example, you saw how an inexpensive off-the-shelf servo and gripper can lift a raw egg, or grasp a cheese curl without crushing it. The grip board can easily grasp and pick up its competition board. The older board does not have the technology to do this. In this video, 3 different grippers are shown. All use the exact same Arduino sketch with no changes. The Serial Wombat firmware and libraries do a runtime calibration at startup to determine the characteristics of the attached gripper. A force feedback-based grip control has many advantages over open loop or fixed position command. Grip force can be regulated, allowing delicate objects to be lifted. Round or irregular objects are less likely to pop out of the gripper if moderate rather than maximum torque is applied to the servo. Servos which are feedback controlled typically will run cooler, consume less battery, and break down less often than servos which are commanded to an unreachable endpoint in an attempt to provide grip. Beyond gripper functions, many other useful servo functions are available. Speed limiting can have different constants in each direction. This is very useful when lifting or setting down an object or robot segment because gravity works with the servo in one direction and against it in the other. Setting a slower descent speed can help prevent shaking or overshoot of the stop point and perhaps even prevent servo damage. Communication timeout can set servos to a default position if the host doesn't check in within a specified period of time. As an advanced feature, it's even possible to set default power-up positions for a servo so that a robot arm doesn't crash to the ground if it goes through a reset or if power is momentarily interrupted. Encoder-based speed control is possible when using continuous rotation servos if an optional external encoder is added. Serial Wombat PCB0031 GRIP is a certified open-source hardware project by the Open Source Hardware Association. The Serial Wombat firmware and libraries are available under an MIT license. The grip board is one of a family of Serial Wombat 8B boards that all use the same firmware images and Arduino, MicroPython, or C# libraries to command them. Any combination of Serial Wombat boards can be used simultaneously in the same circuit. If an output pin is not used to drive a servo, it can also be configured to run one of the Serial Wombat firmware's other pin modes. Extensive examples come with the libraries, and online tutorial videos and sample projects are released frequently. It's time to upgrade from previous generation servo controllers that only provide signal output. Upgrade your robotics project today using the real-time embedded coprocessor feedback control capabilities that only the Serial Wombat grip board provides. My name's John Broadwell, and I created the Serial Wombat open source project and designed this board. I hope you enjoy using it as much as I enjoyed creating it.